Hello out there to you. In this video, we're going to derive marginal cost, average total cost or average cost, and average variable cost. And then we're going to graph these using Geoalgebra. That's a free graphing calculator program you can find on the internet. And we've got price of 105. What's the quantity? Okay, so built into this problem, we need to know some things or think about some things. When it says price of output is 105, they're assuming that it's perfectly competitive. So what that actually means is that marginal revenue is going to be 105. Okay, so that's how much we're going to sell each unit for 105. Each unit will be sold at the same price, so it'll always be 105. Okay. And so the quantity it's asking about, we need to find profit maximizing quantity, which is marginal revenue equals marginal cost. Okay, so we're going to find that. What is the lowest price which the firm will produce? Okay, so this is sometimes known as the shutdown price. What they mean is in the short run. Thing went a little crazy there. And what that is found at the minimum of our average variable cost, which is also the place where it meets marginal cost. So you can solve for those two. If the firm is producing output, what is the lowest level of output? So this is what it wants to know is the quantity at the shutdown price. And then how will your fixed costs? So fixed costs aren't going to change production quantities, but they can change the shutdown price, whether or not we're going to produce at a loss. Okay, so you would say yes. If the fixed costs rise, it can cause the firm to shut down or even exit the market in the short run. I suppose now that I'm saying that, fixed costs wouldn't change the short run, they only change the long run. So really the answer would be no on that one. Okay, well, point of this is to graph. Okay, so we need to derive the expressions here. So marginal cost is going to be the partial derivative of this with respect to quantity. Now, quantity in this problem is expressed as a y. My suggestion would be to substitute, we're going to substitute a q for that, okay, or an x, either one, but makes it a little easier, a little more standard of a type of problem. But I guess I'll use it consistently. So partial derivative with respect to y. So the marginal cost here is going to be turns it into 1. So it'd be y squared minus 20y plus 105. That's our marginal cost. Our average total cost is just to divide everything through by y. Okay, so just take the average of everything. So this would be 1/3 y squared, and then minus 10y plus 105 plus 5 over y. And then average variable cost. The average variable cost, you have to split the total cost function into two. This is the fixed cost right here, because those will be paid regardless of whether they produce anything or not. And so all of these are going to be contingent on how many units of y I produce. So the average variable cost is just divide through just this part of the equation by y. Okay, so 1/3 y squared minus 10y squared. Nope, not squared. Just minus 10y plus 105. And that's it. Okay, so there's our costs. Okay, or our cost function. So now I'm going to pull up Geoalgebra. Now, Geoalgebra it needs the y-axis to be y. So we're got to kind of flip this around. So when I'm entering in my functions here, I'm going to enter it in as y, but y actually means cost. Okay, it doesn't mean units of y. And I'm going to have to substitute this y for an x. So here's our marginal cost curve. So it's x squared, and then minus 20, well, not y, x, plus 105. That's the marginal cost curve by itself. Okay, and GeoAlgebra is kind of cool. I think I can set this and tell it its name is not F, it's marginal cost. How cool. Okay, get out of here now. There we go. See, marginal cost. How cool. All right, average total cost. So this is going to be y equals 1 over 3. And then instead of, I'm substituting y for x because it needs that to, it wants to recognize that minus 10x plus 105 plus 5 over x. Okay. And there is, let's change settings. I think we can change the color too. Yeah. What do you like? You like purple? There we go. Purple's good. Okay, and then we want to change that to ATC. You got it. You can do some more fancy stuff if you want. There is our average total cost curve. It does some funky things. We don't want that piece of it. We just want that piece. That's okay. All right, and then average variable cost is, again, y is the functional form, 1/3 x squared minus 10x plus 105. And where did that guy go? Something's wrong here. Oops. You have to delete that whole thing there. Doesn't like something. Because our average variable cost should be below average total cost. Give me 1 second here. Okay, so I re-entered the function there while I paused the video and saw that it's just really, really close to average total cost. So that's why I didn't see it. So we can fix that. All right, ABC. Okay, and now we got them all. Okay, now at this point, so there's average variable cost, and then purple line is average total cost. Okay, so at this point, it's pretty easy to see what I'm doing here. I don't have to really do much more math here. The lowest price the firm will produce output, we're just going to look for the minimum of average right there, and that's where they intersect. So they intersect, the price is 30 and the quantity is 15. You can see it right there. Price is 30, quantity is 15. Really easy. And then it said, so you could just find the price. Where does the price equal marginal cost? But we can also just go y equals 105, and it's going to draw that line right there. And you can click on that, and it'll tell you 20 units, 105. So they're going to produce 20 units because that's where marginal cost equals marginal revenue. So right here, if you wanted, if you were able to, you could just screenshot this as the graph, and you go ahead and label this. You can do this in another program, but here's price, marginal revenue, average total cost. You might want to zoom in a little bit. Average variable cost, very close there. And then this is marginal cost. This is your profit maximization. So you have tools to zoom in and zoom out, but that's how to plug it into GeoAlgebra and get this answer right here.